This short video explains how a seemingly stable ecosystem can suddenly be propelled into chaos or change, and switch to a new state of stability, also called homeostasis. To illustrate this, we will use a section of the boreal forest located in the Yukon's southwest as an example. Within the boreal forest ecosystem, there exists a relationship between the trees of the forest and the spruce bark beetles that inhabit these forests. The spruce bark beetle completes part of its life cycle by burrowing through the bark of mainly dead, stressed, but sometimes healthy spruce trees. This part of the tree is called the phloem, and it is where the tree sends nutrients up from the ground into its upper parts. The bark beetles lay their eggs in this phloem layer. The tree responds to the beetle attack by producing resin to flush the beetles out. If the tree can't stop the beetles, then it eventually dies, because it can no longer supply itself with the nutrients required for its life. In the past, the cold winter temperatures of this region have been able to keep the spruce bark beetle's population in balance. When the temperature reaches minus 40 degrees Celsius for over a week, a significant number of the beetles will die off, and the beetle population remains in check. However, due to the effects of climate change upon the world, the Yukon has experienced an increase in average temperatures. As a result of the increase in temperatures, not as many beetles are dying over the winter. In addition to this, the spruce bark beetle now reproduces within 1 year instead of within 2 years, as it had done in the past. Warmer temperatures and changes to the beetle's reproductive life cycle has led to a massive increase in the spruce bark beetle's population. The spruce bark beetle population has exploded in the Yukon since the 1900s and has created hundreds of thousands of hectares of dead boreal forest. There are several possibilities as to how this ecosystem could respond to this change and tip from one state of homeostasis to another. These possibilities lead us to some further questions. Possibility number 1, forest fire. The potential for catastrophic fire is large. How would a catastrophic fire change the boreal forest? After a fire, what would the landscape look like once it again reached a state of homeostasis? Possibility number 2. The forest keeps decaying. Note that the process of decay is much slower in the northern latitudes, and that white spruce trees tend to shed their dead branches only with wind. Ergo, not much light hits the forest floor to speed up successional growth. This results in little to no growth on the forest floor. Is this a state of homeostasis? Or is the forest still in a state of change? Possibility number 3. The spruce bark beetle has now consumed most of its food supply. The remaining young tree's immunity is too strong for the bark beetle, and the bark beetle is not able to successfully complete its life cycle. Will the spruce bark beetle disappear and give the remaining young trees a chance to again rebuild the forest? Conclusion. In this short video, we explored the concept of ecosystem homeostasis through the changes that are currently taking place in the boreal forests of the Yukon's southwest. The boreal forests in this location are at a tipping point, in part due to the effects of climate change and the explosion of the spruce bark beetle. In the future, what will the boreal forest ecosystem's state of homeostasis look like? And will there even be a boreal forest?